Welcome, guys. We have another fresh question here, which is actually based on total derivative. So the question number one here says that given a function with an initial point of 3 and 1 to be equals to 7, and then you have the partial derivative of that function with respect to x of that same point to be equals to 9, and the partial derivative of that function with respect to y is minus 2. So now the question asks us to find an approximation for this function. That is, we have an adjustment in the initial approximation given to us. Before it was 3, 1, and now it has been adjusted to 3.05, and y has been adjusted from 1 to what, to 0.9. So whatever we just have to do here is to just get an hopefully more accurate answers to this. So to find solution, or to find an approximation answer to this, the first thing we have to take notice. Let's start with the solution. So you have to take note of this. At first, you have a function. So suppose we let, first thing you have to do is to let z to be equals to a particular function in terms of what, x comma y, such that we have an initial value for x and initial value for y. So you can decide to call that x naught and y naught. So z is equals to f of x naught then y naught. So trivially, as you can see, we have f of 3, 1 here to be equals to 7. This simply implies that we have f of 3, 7, which implies that x naught is 3 and then y naught is also what, 7. And at the same time, whatever we want to approximate now is this function we have here. We now have f of 3.05 comma 0.9. This implies that we have another value for x1. Let's call this x1, let's call this y1. So mind you, you have to take note of this in such a way that this is your x naught value and your y naught value, and this is for x1 and this is for y1. So we all believe that the total derivative, which is represented as dz, of two functions is denoted as fx dx plus what, fy dy. So this is total derivative for two independent variable x and y. So then you stop here. Suppose you have a function in terms of x, y, z, such that this z is another letter entirely. Let's say w. Then you have fx dz plus fy dy plus fz dz. So that's how it works. So here in this case, my first observation is that I need dx and I also need what, dy. Change in x and change in y. But this change in x simply implies the difference in the point given to us, the adjustment. Okay, so actually we believe that an adjustment is made from 3 to 3.05 and from 1 to 0.9. So the difference in that adjustment is what, is this, dx is equals to x1 minus x naught. So just use that concept. So it is not clear enough what's happening. So dx simply implies the x1, the value of x1 you have minus the value of x naught. So dx becomes, x1 is 3.05, and remember that x naught is what, is 3. So by the time we decide to subtract 3.05 minus 3, we have 0.05. Hence this dx value now is 0.05. Very straightforward. What if we are trying to look for dy? The same thing. Similarly, we have to do the same thing for dy. Dy simply implies the y1 value minus the y naught value, and y1 is what, 0.9, and we have y naught as 3, 1. This is not 3, 7, please. This is 3, 1. We have 3, 1. Sorry for that. So here in this case, we have y naught to be equals to 1. Y naught is 1. So on subtracting, we should have 0.1. 0.9 minus 1, we have minus 0.1. So this implies that dy is what, is minus 0.1. So you just come straight here and say, okay, the z is equals to fx, while the x is what, is what we have over there, which is 0.05. And at the same time, we have fy. So this dy now is what? We have it as minus 0.1. Now we have one more thing to do. Considering this now, I need fx. And fx is given already. Fx in terms of the two independent variables, which is x and y the point is 3, 1. So the fx value, ordinary fx, this is it here, is equals to 9. You don't have to be confused of this 3, 1 because the initial way, the correct way of writing this thing is, this definition here is, we're supposed to have written it like this. Fx, it must be in terms of two independent variable, then multiply by dx. So this is the best way of writing it. Then plus, you also have fy, and fy must be in terms of two independent variable, and you also have dy. So this fx now, where x is 3, 1, the whole of this thing is given already. See it is 9. So that means fx is 9, right? So you multiply it by 0.05. What is fy? Fy of 3, 1, that is minus 2. So you have minus 2 times minus 0.1. So by the time we multiply this together, multiply this and then you subtract. So trivially we have 9 open bracket 0.05, then plus minus 2 minus 0.1. So trivially it is clearly seen that the z gives us 0.65, yeah. So we have change in y, dy as 0.9 minus 1, so which is actually correct. So we have it as 0.65. Okay, so the next thing for us to do from here is to find an approximate for this function. And we all believe that there is one particular definition which says that whatever you have as your approximation, the change in z itself that we have actually introduced, the result is always equals to the function we have initially itself, f of x comma y, then it is always added with the what? With the total derivative. So that's all. So the final answer to this simply implies that you have f of 3, 1 plus the final answer we have. So therefore, change in z is equals to, an approximate value for this is, f of 3, 1 is given as 7. So it will be added to what? 0.65. So on adding this, so an approximate for this function here is 7.65. Sorry, this is an approximated value, an approximate. So you are not making use of equal to sign, just an approximate. It's not always equals to. So take note, change in z is an approximate value for 7.65. So this gives the final answer to this question. So for the next video, I'll try to give a very clear explanation on question number 2 and the rest of the questions given in the assignment. So thank you. Thanks for watching.